Today we're going to do linear combinations, also referred to as elimination. So the first example, we have two equations, 2x plus y equals 14 and negative 2x plus y is equal to 18. You may notice that your x's are opposites. One is positive 2x, the other negative 2x. So if we add these equations together, this is called linear combinations, we will get the equation 2y equals 32. Then solving this equation, divide both sides by 2 to get y is equal to 16. Now remember, we're looking for an ordered pair, so take this y value, 16, and replace y in one of your equations with 16. Solve that equation, and in this case we're going to get x is equal to negative 1. So that means the ordered pair negative 1, 16 is the solution to this system. Now to verify, you can check by graphing one or all of the equations in this problem. Now this time I've graphed everything, or most of them. So the original two equations and a couple of the other equations that we got as we were doing linear combinations. And you'll see that all of the equations contain the solution negative 1, 16. So in example 2, we have two equations, and this time notice the y terms are opposites. One is positive 5y and the other is negative 5y. Well, that makes linear combinations easy because when we add the equations, the y terms will be eliminated. This is one reason we call this elimination, because it's eliminating one of the two variables. To solve that remaining equation, divide both sides by 9. Now that we have an x value, plug it back in to one of your original equations. It does not matter which one, but I chose the one on the top. 2 times 3 is 6. Subtract 6 from both sides. Divide both sides by 5, and you get a fraction, or you could have written this as a decimal. This fraction is 8/5. So the ordered pair 3 8/5 is the solution to the system. Now to check, you can graph both of your equations in Desmos, and you'll notice that they do cross at 3 8/5. Desmos did convert that into a decimal 1.6, so if that's what you wrote, that's the same number. It can be written either way. Example 3. The two equations this time do not contain opposites. The 2x and the 4x are not opposites. The negative 5y and the negative y are not opposites. So in order to do linear combinations, what we want is to change one equation or both equations so that we have opposites for one of our variables. So what I've chosen to do is multiply the second equation by negative 5, and you'll notice negative 5 times negative y produces positive 5y. Now I have opposites. My y's are opposites. So I'm going to add the two equations together and get negative 18x equals negative 18. Divide by negative 18 and get x is positive 1. Take my answer to this solution and plug it into one of the original equations. I've chosen the second equation, 4 times 1 minus y equals 6. I subtracted 4 from both sides, or actually I subtracted 6 from both sides and added y to get y is negative 2. So the solution is 1, negative 2. Now to verify or check, you can graph both original equations, and you will see that the 2 points cross, or the 2 lines cross at the point 1, negative 2.